Welcome to the Stormsurf video surf forecast for the week starting Sunday, January 15th. Looking at significant wave heights for the North Pacific Ocean, we see a gale in the Gulf of Alaska producing 27-foot seas aimed more to the northeast than east, but still generating swell relative to the U.S. west coast, and also a broad gale developing off Japan producing 28-foot seas aimed well at Hawaii. Let's get into the details. But before we talk about the future, let's talk a little bit about the past. Specifically, Monday, almost a week ago, off Japan, a gale developed, producing 36-foot seas aimed east. That gale built, producing up to 44-foot seas, again aimed more at Hawaii than the U.S. west coast, not so much by virtue of the aim, but the distance, a long ways away from the U.S. west coast, well west of the date line, closer to Hawaii. Anyway, that system continued into Tuesday, faded a little bit Wednesday morning, then started redeveloping while falling southeast towards Hawaii with seas, what was that, in the 38-foot range? It says 40 feet, 39 feet, let's say. Then faded just a short distance away from Hawaii before tracking northeast and dissipating. Swell from this system has already hit the Hawaiian Islands, is now just starting to show up on the buoys and along the coast in Northern California. Nothing huge, but, rideable waves just the same with decent conditions. And now, back to the future. Specifically, looking at the jet stream right now, looking very good, consolidated finally, and pushing over the date line, consolidated with 190 knot winds in its core, reaching almost to a point north of Hawaii, a little bit north, we'll say northwest of Hawaii, but a nice little trough here showing up in the Gulf of Alaska, being fed by 120 knot winds, nothing outrageous, but that is good enough to support gale development. And as we saw in the wave model chart, there is something going on in the Gulf of Alaska. Also, a little bit of a backdoor trough. That is, here's the northern branch of the jet stream moving into Canada, but then falling just off the California coast. This is a backdoor trough, and that would support low pressure down at the surface and low pressure aloft, just like this trough here, which also helps generate wind generates seas generate swell as it radiates away from the fetch area and, of course, produces surf. Now, this trough here is doing nothing in terms of swell production because it just popped up on the chart and it's going to be gone before you know it. But still, just something to notice. This has kind of been a pattern here in California. Backdoor troughs forming, basically drawing cold air down from the Arctic into the area. That, in combination with a healthy moisture flow, has produced a lot of snow in the Sierras. 15 feet into Tahoe over the past 2 weeks, basically, a little bit less than that. Great base of snow at all the resorts, down low, down at lake level, 6,400 feet, and also into Mammoth. If you haven't gone to get some of that snow, go, but don't be too worried about it because there's more coming. All right, back to the jet stream. So here we go. Good setup. The jet stream building to 200 knots in Sunday night into Monday, moving over the date line. The split pattern that was locked over the date line here for weeks is gone now. As we get into Wednesday, notice here now the jet consolidated, moving the whole way across the date line, poised just off Northern California on Wednesday. What that really means, not so much from a swell perspective, but that should reopen the storm door for California, but in a little bit different fashion than what we were seeing before. Before it was all sort of cut off backdoor energy. Now this is going to be a direct assault. Also notice a bit of a trough here on Wednesday developing west of the date line, also in the Gulf of Alaska. And as we roll this out here, you see that trough moving right into California come Wednesday night, Thursday. Certainly a weather producer is expected. 190 knot winds feeding that trough. Certainly something should happen from that. Then we get into Friday. Notice the jet. Now something starts happening. It really starts weakening here over the date line, but we've got strong energy pushing into the U.S. West Coast and stronger energy starting to rebuild off Japan just a little bit. Now notice here we go into Saturday. The jet splits and you go, oh no, here we go. Back into the same old pattern. Trough building here in the Gulf of Alaska. But what does happen as we get into Sunday, wind energy starts building here off of Japan, again pushing over the date line, and we suspect this split, it's not even a fully split because notice it's reconsolidated just on the other side, just sort of a little tear in the jet, if you will, and a trough building in the Gulf of Alaska. We expect that to probably be pretty short-lived. Wind energy again back up to 170 knots, pushing over the dateline a week out, and certainly a good amount of energy plowing directly into central California. This will be bad for swell in terms that local conditions will probably be horrendous along the U.S. West Coast, but precipitation-wise, great for the mountains. So, but also notice with 140 knot winds in the jet, winds will probably be very high over the Sierras. Lifts on the upper sides of the mountains will probably be in jeopardy of operation. Next up, let's take a look down at the surface. Surface level pressure, surface level winds on this chart, and exactly as expected, the trough in the Gulf is producing not a gale, but a storm. Little area 50 knot winds there. 972 millibars, pretty deep low. Also a broad gale off Japan, building also at about 968 millibars. Fetch not as well organized as you can see here. 35, maybe some 40 knot winds. Roll this out. The gale or the storm in the Gulf falls down to gale status by Sunday night, 45 knot winds, and is making its move towards Canada. While the broad gale, now look at how large it is, extending some sort of fetch, we'll call it 30 knot fetch, extending from Japan all the way to the dateline and even a bit beyond there. Now, those winds really aren't strong enough to do much, but still, it'll agitate the ocean surface and produce swell, and you see there 40 knot winds in the core. So it's really just the small core that's of most interest. We get into Monday, then the gale kind of rebuilds supposedly on Monday night, 40 knot winds, moving into the Gulf, and this sets up, you can see as we get into Tuesday night, you can see a lot of fetch, a lot of energy here. Just about poised to push into California. We saw what the jet stream's supposed to do, so let's see if if systems actually do what they're supposed. And as you can see, yes, a front off California. Now, weather sort of takes a break here in the West Pacific come Wednesday. The focus turns into the U.S. West Coast, a little system Wednesday night. Then here we go, a fairly strong system, 50 knot winds Thursday night with a buddy companion or a secondary fetch off that, all moving towards the U.S. West Coast. Notice high pressure here, so you get this sort of a gradient, what you call difference in pressure between high pressure and low pressure. That creates wind and sort of accelerates at the high, kind of feeds the wind circulating counterclockwise around the low, and you just have this long fetch pushing right into California. Also notice on Friday, new broad, almost a storm, a little patch of 50 knot winds, but mainly 45 knot winds pushing off Japan. This bodes hope for Hawaii. Anyway, roll this out. There you go, 55 knot winds, good solid storm by Saturday, supposedly off Japan. Piles of energy, storm energy mainly, pushing into the U.S. West Coast, continuing on into Sunday. Here we go. We're about a week away. Broad gale forecast over the dateline, 45 knot winds. A little bit of a pause for California, or so it looks, but much precipitation in this area. And then that's the final frame, 7.5 days out. Certainly looks like an active pattern, both for swell production relative to the U.S. West Coast, for snow production relative to Central and North California, and Southern California, of course, will see some swell energy because they'll be a bit protected from the weather up north, but not completely. There is wind and rain expected for Southern California as well. Let's go take a look at the wave model charts now. And here we are, wave model charts. So this takes the wind speeds, wind directions from the wind model, infers that what its effect is on the ocean surface, and translates that into sea heights, significant wave heights. The total of all different swells in the water directly built by wind energy. So here we go. As expected, gale in the Gulf, 27-foot seas. Gale, broad gale off of Japan, 28-foot seas, put this into motion. And by Sunday night, we see 32, 34, almost 35-foot seas in the Gulf of Alaska. That's good for swell pushing into the U.S. West Coast, probably midweek. A day or two's worth of activity right before the weather starts kicking up along the coast. Also, next swell being generated relative to Hawaii, 30-foot seas. Secondary fetch up here building 34, 35-foot seas, sort of falling southeast a little bit towards Hawaii there. So another pulse of swell energy, probably not as big as what they just had, but still swell just the same. And then the focus moves towards the Gulf of Alaska, and you can just see. Now, remember, there's a stronger system forecast for the Gulf on Thursday, 40-foot seas. Again, things will be very agitated here north of Point Conception. Southern California or protected spots are the most likely place to find decent surf. Seas of 30 feet or greater pushing into the U.S. West Coast come late Friday into Saturday. Our next system starts building off Japan also on Friday night. Seas into 42-foot range, targeting Hawaii very well. Oh, and let's go back this frame here. You see 20-foot seas from Oregon the whole way down to almost Point Conception. Assume a lot of wind, very rough sea state. Anyway, storm moving towards the date line comes Sunday, a week out, with 34-foot seas over a broad area. Swell for Hawaii for sure from when it was off Japan. More from this, more energy pushing towards the U.S. West Coast. You look at all this, you just go, there's a lot of swell coming. Maybe not huge, maybe very raw for the U.S. West Coast. Cleaner for Hawaii. Probably that's the better call. Southern California, maybe, maybe not. Hard to tell. Weather could be an issue. Let's look longer term. Specifically, let's take a look at the Madden-Julian Oscillation. This oscillation travels around the planet on the equator from west to east, spending 3 to 4 weeks at any one period in time in the Pacific. And when it is in the Pacific, the active phase of the MJO, that helps support storm formation. When it's in the inactive phase, it helps tear the jet stream apart, and that's why we got that split we saw the past couple of weeks over the date line. Also in play, La Nina, of course, but you know what? It's almost dead. In the ocean, there's hardly a sign of it. In the atmosphere, it's still in play, but it will be trickling down over the next several months. Let's get into the details. First off, let's take a look at winds across the equatorial Pacific. We're looking for the Madden-Julian Oscillation. So actual winds, here's the equator, West Pacific here, that's New Guinea, East Pacific here. This is from the TAO buoy array, a string of buoys on the equator, the whole way across the Pacific. And this is 5-day mean winds, basically east winds. Looks pretty strong, especially here in the Kelvin wave generation area. This area from about just east of the date line, 5 degrees north and south of the equator, the whole way to 135 east, north of New Guinea. This is what we use specifically to look for the generation of Kelvin waves, that is warm water. That is an early sign of El Nino pushing to the east at depth. We look for westerly wind bursts here, but also you can get slackening of the trades in this area in winter months, and that also is a sign of the active phase of the Madden-Julian Oscillation. We look at anomalies, differences in wind speeds for this time of year, and you see basically a normal wind pattern here across the equatorial Pacific, but in the Kelvin wave generation area, we see east anomalies blowing from the east. That suggests at least that La Nina is in play, if not the inactive phase of the MJO. But then you look at the jet stream and you see what's forecast and you go, something isn't connecting up here. The jet shouldn't be raging during the inactive phase of the MJO. So the guess is here, if anything, these easterly anomalies are attributable to La Nina and not to the MJO. And just a quick look at what wind anomalies have been doing. This is at 850 millibars. This is up about 4,500 feet, but still is a good proxy for what's going on down at the surface. Kelvin wave generation area. So here again, South America, Australia, New Guinea right there. Kelvin wave generation area right in here. We see easterly anomalies on January 9th. What is that, like Sunday or Monday of last week? And as we just scroll through here, you see easterly anomalies have held in this area, and that's what the models have been forecasting for a while. So again, one would think the inactive phase of the MJO is in control, but you certainly wouldn't expect it based on what the jet stream is doing. So that tells me this is more La Nina attributed than the MJO. And a quick look from the GFS model here. Okay, this is the date line running right down here. The West Kelvin wave generation area is about here. This is about 120. So down between these two, the West Pacific. Well, this is the whole planet on one chart. Blues are easterly anomalies. Orange yellows are westerly anomalies. So you see there's this hard line pretty much halfway across the Kelvin wave generation area where you have westerly anomalies on one side, easterly anomalies on the other. Here is the forecast. Here is today, actually. When you look at the forecast, you see easterly anomalies moving off to the east. Maybe indication of something else going on, too. We'll look at that in a minute. But you see westerly anomalies supposed to recede, but in the Kelvin wave generation area. But we looked down at what the jet stream is supposed to do. It's supposed to be building. So again, we're not going to say this is attributable to the MJO, or maybe not even La Nina, maybe something else. Another way to look for the MJO is through these charts, outgoing long wave radiation. See how much, basically it's showing you how much cloud cover there is compared to normal. The yellows and oranges suggest more reflectivity off the ocean surface, meaning high pressure, meaning the inactive phase of the MJO. Blue, less reflectivity, meaning more clouds, meaning the active phase of the MJO. So according to this, some weak flavor of the active phase of the MJO is in control over the dateline, expected to fade and die out and be completely neutral 2 weeks out, this per the statistic model. The dynamic model, GFS ensemble model, basically predicts the same thing. Active phase of the MJO fading over the dateline, but with the inactive phase moving from the Indian Ocean into the West Pacific, but then dying very quickly 2 weeks out. Not so sure how this is really going to happen. We'll see. The pattern, though, has been for the MJO to be very weak over the entirety of this winter. We don't expect much of a change. To see an inactive phase this strong would be kind of unusual, especially seeing how La Nina is fading. Next up, we look at phase diagram charts. Assume you're looking down on the North Pole of our planet. The MJO moves counterclockwise around this chart from the Indian Ocean over the maritime continent, say Bali, over the dateline West Pacific, under the U.S., across the Atlantic on the equator, over top of Africa, and back to the Indian Ocean. Does this cycle. The Pacific cycle, 3 to 4 weeks. The big dot is where the active phase of the MJO is, so per this, but if it's inside the circle, it's very weak. So this suggests the active phase of the MJO is like what we saw on other charts, somewhere in the West Pacific right now. The trade anomalies, those easterly anomalies, are not attributable to the active phase of the MJO. The forecast, though, has the active phase here in about a week moving to the West Indian Ocean very quickly and getting strong there, which should suggest the inactive phase of the MJO will be on its polar opposite, probably in the Pacific Ocean. But then another week beyond that, the active phase, very weak, is supposed to start making its way back to the West Pacific. The other model here, the GEFS, depicts the same thing, maybe not quite as strong, but basically the same general pattern. The upper level model, so the oranges and yellows are areas less favorable for precipitation, the green more favorable, so you can assume this to be the inactive phase of the MJO, but this runs about 2 weeks ahead of what's going on down at the surface. So what this suggests is about 2 weeks out, the inactive phase of the MJO is supposed to pop into the West Pacific, start working its way across the Pacific through mid to late February, and then while that's happening, the active phase of the MJO come about Valentine's Day, mid-February, shows up in the West Pacific, starts taking control. It's mainly this area here in the West Pacific we're most interested in. So that would sort of suggest right now we have the active phase, it'll die. 2 weeks out, the inactive phase comes in, takes over for a couple weeks, and then the inactive phase behind that. And then one of our favorite models, the CFS model, again, looking at wind speeds, 850 millibar winds, up at about 85, at the 850 millibar level, 4,500 feet in the air. So again, yellows are westerly anomalies, blues are easterly anomalies. This chart goes in the past here to the future. Kelvin wave generation area, here's the date line, and Kelvin wave generation are about between these two tick marks going straight up the chart. We'll overlay the MJO. According to this, the active phase of the MJO right now is on the dateline region in the Kelvin wave generation area, but as you see, easterly anomalies are right in the middle there. Very strange. Westerly anomalies have been there and are forecast off to the east. Supposedly there's this little inactive phase of the MJO that's supposed to sort of split up, but we don't believe that. Dashed lines are the inactive phase. So we think this is really mainly the active phase hanging on the date line from now into maybe even March, maybe a little weakening. But notice easterly anomalies in control. Now we'll overlay Rossby waves, and you can see right here this maps very well with what's going on at the surface, and we suspect some sort of a Rossby wave might actually be sitting over the date line, and that's what's feeding the easterly anomalies. So you can have multiple waves on top of each other. We have La Nina, which is the very long wave, the MJO, which is the medium wave, the Rossby wave, which is even the shorter wave, all interacting. But notice the pattern has been, the MJO has been very weak, so it's not surprising that there's these other forms of modulation that are sort of coming in, disrupting what normally we consider a perfect or ideal flow. Anyway, so here's the other part. Come about February, so westerly anomalies are supposed to start creeping off to the east. Now, the model's been suggesting this for months, and it doesn't happen, but we also know that La Nina's dying, and it would not be surprising to see this being the last hurrah of easterly anomalies in here till like maybe late February, and then a more normal MJO pattern starts setting up. Now let's take a look at the ocean, and we're not so much interested in the MJO anymore as we are La Nina. Specifically, ocean temperatures, actual temperatures, West Pacific here, East Pacific here. We're looking down at depth. These are the same TAO buoy array. You see the sensors on the strings of the anchor lines running off the buoys down, so you're talking 300 meters, 1,000 feet deep and more. Anyway, you see warm water here in the far west. The depth of warm water, very shallow in the east, is pretty typical of La Nina. If it was El Nino, you'd see this dark line here, or even this line here, the 28-degree isotherm, stretching off to the east. But now you see that all warm water is pretty much pooled up in the west. That's because trades are blowing on the surface, and anomalies supposedly are blowing pretty good from the east, and that pushes all warm water, just pushes it the whole way across the Pacific over towards New Guinea. Differences in normal for this time of year, though. You look at this chart, you go, oh, it looks kind of normal. And you know what? It is. Warm water here in the west. There was a bunch of cold water here, not super cold, but down to -4 degrees below normal. And all of a sudden, this warm water is starting to upwell, build, not warm, just normal temperature water in the East Pacific. And almost we have a normal water temperature pattern now. That's a clear signal that La Nina is fading out. If you had lots of really strong easterly anomalies, you get a lot of upwelling in this area, you get negative anomalies. That's all gone. We don't have any Kelvin waves. That would be El Nino. But we just have sort of a static neutral pattern, and this is developed just in the past 2 weeks or so, which is a very good sign. Here's another version of that same diagram. It does show 3 pockets of, call them 1 degree below normal anomalies, but still you see warm water working its way off, and you get the sense that whatever cool water is left is very shallow, it's fragmented and falling apart. We have more data to support that thesis that we'll show you in a second. This is a great chart too. Upper ocean heat anomalies, upper 300 meters of the ocean. You can see back a year ago, the last Kelvin wave number 6 from El Nino, that is warm water pushing off to the east, driven by the active phase of the MJO, and persistent westerly anomalies over here. And then it all collapses because basically there was no more warm water left in the West Pacific. This is the West Pacific here, East Pacific here. And instead, on comes cold water. So we had our La Nina bout in May, June, and now look at it. Here we are, current January 2017. Warm water in the west, working its way off to the east. This light shade of blue is neutral to maybe half a degree below normal, not even that. So officially, La Nina is a half a degree or more below normal for, 3 consecutive 3-month periods overlapping. Certainly looks like that is going to get a run for its money, as if La Nina is fading out. Sea level anomalies, JSON2 data here. Here's Mexico, South America. Australia here. Strip out all waves, strip out the tide, strip out wind swell, everything, and just look at the height of the ocean. Wherever it's negative, that suggests colder water at depth. So this has been the pocket that we've been watching. It was the whole way from Peru extending out over here a month or two ago, and it's slowly just fading away. There's one little pocket here, one little pocket near the Galapagos, and that's it. This also suggests that what we've seen in the previous images, that cold water at depth is dissipating. And then here's where things get really kind of interesting. Sea surface temperature anomalies. Differences in normal for this time of year. Now, here, if you had La Nina in play, you would see lots of cold water here. You'd see it streaming up off of Ecuador. Then you'd see it rushing over the Galapagos and heading out towards the dateline. Do we see that? Not at all. Instead, these reds, there you go, suggest warmer than normal water, and the cool anomalies are limited to just along the immediate Peruvian coast. But now off of Ecuador, warmer than normal water is in control. The same thing over the Galapagos. There's this cool flow pushing off of Central America, but it barely, where's 5 degrees? Right there. It barely reaches down to the 5-degree mark, and we see warm water working its way out to 115 west, almost 125, and pockets here and there. It just suggests, if nothing, at a minimum, La Nina is taking a major pause. Here's the trend over the past 7 days. You can see just what we talked about before, clearly setting in warmer than warm. The trend is for warming along Peru, warming off of Ecuador, much warming over the Galapagos, and working its way out till, well, a point south of Hawaii. Now, we were seeing alternating pockets of cool and warming here. That was the thought of sort of easterly wind bursts stirring up the ocean in pockets. That's all over now. And again, it appears that La Nina, if this were a strong La Nina, you'd want to see cold water in here and a cooling trend, or at least a neutral trend. The only place we see that is streaming off of Central America here and southern Mexico, and displaced off to the north. And the big level picture here shows it even more. Warmer than normal water is almost, now don't take this is not El Nino, okay? But it almost looks like an El Nino sort of building pattern with warm water setting up here. We expect this to be very short-lived and that something will happen. But for now, warmer than normal water slightly, half a degree or so, with a little pocket of maybe 1 or 1.5 degrees. This data is very dynamic, as you know the ocean is. But warmer than normal water pushing out to 125, and here's the remainder of the westward displaced La Nina cool pool sitting south of Hawaii, with the jet stream blasting this way north of Hawaii. Whatever effect this might be having on, supposedly, you would expect high pressure north of the cool, up here in the Arctic, north of the cool pool. That's not happening. Instead, we have probably an active winter weather pattern setting up with low pressure in this area, meaning that La Nina, whatever impact it's having on the atmosphere, is extremely weak. So let's look at the effect of La Nina on the atmosphere. Southern Oscillation Index, good way to measure what's going on. Difference in pressure between Darwin, Australia, and Tahiti. If you have positive numbers here in the daily index, that suggests at a minimum the inactive phase of the MJO. Over a long period of time, it suggests La Nina. Currently, so we had a nice little run here. We'll sort of look through the numbers. You see, we had a little run here of pretty strongly positive numbers back in late December, early January, and go, gosh, the inactive phase of the MJO is really setting up. But now we've had a 4-day break, and it's starting to move negative. That is a good sign, suggesting maybe the active phase of the MJO is taking hold. In fact, this Southern Oscillation Index has been the best thing that we've found this winter for measuring the strength of the MJO. The MJO has just been exceedingly weak, and it's hard to tease out exactly what's going on. So we've been using this, and it seems to work pretty well. The 30-day running average for right here, you can look down here. If you see positive numbers, that suggests the inactive phase of the MJO, as we saw in early January. And now you notice the numbers starting to, just the past couple of days, starting to trickle down, fall down, basically because of these 4 days worth of negative numbers. 90-day running average. Next up, this is what we use to measure the strength of La Nina or El Nino. Negative numbers are, of course, El Nino, positive La Nina. You look at the trend, it's hovering, give or take a 1 to 2 digits of readings right around 0. That also suggests that La Nina is very weak. The ESPI index is very much like the Southern Oscillation Index, only it's measuring actual amount of rainfall in the area north of Australia versus out off of Tahiti here, or actually a broader area. If it's wet in this region, your index turns positive, and that suggests a lot of rainfall, of course, suggesting El Nino. If it's dry here, the index goes negative, suggesting La Nina. Current value, minus 0.9. It was down to minus 1.9 here at the peak of La Nina a month or two ago. Slowly working its way. We're hoping towards 0, but it's been holding at about minus 0.9 here for a couple of weeks. So no clear trend, and you can see the dryness right here in this anomaly picture, rainfall anomalies for the last 30 days. So not a lot of sign of the death of La Nina in this image, but other data that we've seen already and discussed clearly shows La Nina is fading out in the atmosphere. Just a quick trip back, forgot to show this before, 30-day moving Southern Oscillation Index, the average, so you can tease out, here's the this would be the inactive phase of the MJO when it's moving up, when it's moving down, the active phase of the MJO. Here's where we are today. Looks like we've been in kind of this steady inactive phase of the MJO here. So in November, remember when there was huge surf on the U.S. West Coast, bombing for a month? That was all this long-running active phase of the MJO. Since then, we've been on this steady upward climb. At some point, we're expecting this to start turning down again, but maybe not immediately. And then finally, the forecast for the Nino 3.4 region. This is the area between 120 west and 170 west, 5 degrees north and south of the equator. This is how you measure El Nino, La Nina officially. It's by ocean temperatures. So here we were back last year in the winter. El Nino, strong warm anomalies, 2.5 degrees above normal at the ocean surface. And then La Nina came in July of last year, 2016. Temperatures, if this is a La Nina, this is an extremely weak La Nina, barely a half degree below normal, barely making the threshold for La Nina. And now here we are, January. This says we are neutral, and the forecast shows us going to about plus 0.35 degrees in that region and holding into the fall of next year. So this suggests La Nina is already dead, and we're certainly not moving towards El Nino because you'd have to be up at the half a degree mark, but we're biased slightly in favor of that from here forward, which is good news. Now, just because the ocean temperature is changing, it takes a while for the atmosphere above it to change. It's a slow moving boat. It's probably a 6 to 9 month transition, just like when we were coming out of El Nino. El Nino officially died, I don't know, back in March or April of 2016, but there were still effects of it being felt into the atmosphere into November or even December. Now we're doing the other thing. La Nina has peaked out. It's fading. The atmosphere will take 9 months to change. So we're talking September, fall of next year. Maybe we'll see a little bit more active surf pattern. So let's also not get confused with, because we're getting rain into California, that doesn't have anything to do with El Nino or La Nina directly. Okay, normally someone says, gosh, we're getting more rain now than what we got during El Nino last year. And you know what? That's absolutely true. We're at 130, somewhere at 120, 130% of normal precipitation so far this month. And for the winter overall, we're above average. Okay, but last year's El Nino was westward displaced, and when you have a westward displaced El Nino, that tends to make more of the precipitation, push it off the California coast, and it's happening out in the ocean. We don't see any of it. Likewise, we have a westward displaced La Nina, so it's not locking down California as hard. In fact, it's out over the date line, which means we get these continued backdoor troughs pushing out of the Gulf of Alaska. In fact, some of the The last big dump of snow up in the Tahoe area was the La Nina after the 2009-2010 El Nino, and we had massive amounts of snowfall. So it's not unusual to get a lot of precipitation during weak La Ninas, especially if they're westward displaced, because there's still a lot of moisture in the atmosphere from El Nino, and other things are going on. So it's not a straight one-for-one correlation. It's a complex picture. But this picture they're looking at here suggests we're through the worst of it, and good times are set to roll swell-wise. Also note, swell production this year, yeah, it bombed in November, but the rest of the year, we haven't had a whole lot going on. It's kind of been hit or miss, especially for Southern California. So that's a clear sign of La Nina. The precipitation, not so much. All right, so that does it for this week. Looking at the charts, jet stream pattern getting very active. Solid consolidated jet forecast all week, rushing across the Pacific, slamming into California. Series of weather systems forecast slamming into the California coast. Precipitation expected, snow at higher elevations. Initially falling well down to lake level by Thursday or so, and continuing well beyond that. Swell-wise, series of storms on the chart. Lots of swell in the water, probably best for Hawaii. Lots of swell for California too, but raw conditions given the storms impacting the coast. So that's it for this week. We'll do it again next week, same time, same channel, unless we happen to be out chasing surf or snow. But for now, we say next Sunday. If not, we'll get to it as soon as we can. Thanks for watching. We'll see you again.